Bismillahirrahmanirrahim. In the last part of this topic with computing the limit, we spoke about the definition of the limits, and we say that limit is the value of the function as x approaching some real number, some real value. And we say that limit of f of x, and we wrote it as limit f of x as x goes to a. And we say that x can approach the number a from left or from right, and we call this left limit and right limit. If these two limits are equal, then we said that the limit has a limit, or the limit of the function is or exists. If the left limit and right limit are not equal, then we say that the limit of the function as x approaching the number a without positive or negative does not exist. And to explain this with some examples. Compute the limit. Compute the limit. Number 1. What is the limit of number 2 as x goes to 3? We mentioned in the last part that for the constant function, the limit of the constant function will stay the same, no change. It is only 2. So limit of 2 as x approaches the number 3 is equal to 2. My function is 2. My real number is 3. So I need to find the limit of the function, the value of the function when x approaches the number 3. Since I have constant function, it will stay unchanged. It is 2. Number 2, limit to x as x goes to 3. See this one? Now I have polynomial. From the last part, we said that if I have polynomial, the limit of the polynomial is direct substitution for the given number. So I'm going to replace x by the given number, which is 3. So this one will give me 2 multiplied by 3 is equal to 6. For the polynomial, no need to check the left limit or right limit. If I have polynomial, always the limit exists when x goes to a finite number. So no need to check the left or right to see or to say that the limit exists or not exists. One more example. 2x squared minus 4x plus 1 when x goes to, let's say, minus 1. X approaching or is approaching the number minus 1. And I need to find the limit of this polynomial. I have polynomial 2x squared minus 4x plus 1. For the polynomial, all what we need just direct substitution. So this one will give me 2 multiplied by minus 1 squared minus 4 multiplied by minus 1 plus 1. So 2 multiplied by minus 1 squared minus 4 multiplied by minus 1 plus 1. And this will give me 2 minus 4 times minus 1 is plus 4 plus 1 is equal to 7. So the limit for this function is equal to 7. So the limit is equal to 7. More example, number 4. Suppose that you are given this function, piecewise function. Let f of x be equal to x minus 1 when x is less than 0, and x squared when 0 less than x less than or equal to the number 2, and it is 2x when x greater than 2. And we need to find a limit f of x where x goes to 0. Let's find the limit of this function when x equal or goes to 0. But you can see that for this function, it is a piecewise function. Before 0 is different after 0. When x is less than 0, I have x minus 1. When x is greater than 0, I have x squared. So to find the limit when x goes to 0 without any sign, positive or negative, all what I need to check the left limit and the right limit. Left and right, because the function is different in the left from the right. So for this one, I will say, because this function is different, I have left limit f of x as x goes to 0 minus. This one. So I need to find the limit when x goes to 0 minus. 0 minus means x less than 0. It means this part. 0 minus means x is less than 0. So this is equal to the limit of the function x minus 1 of this part when x goes to 0 minus. Now x minus 1 is polynomial. To find the limit of the polynomial, we just direct substitution. Now substituting the value of x. So this will be replace x by 0. 0 minus 1 equal to minus 1. So the left limit is equal to minus 1. Left limit is equal to minus 1. The right limit now, when x goes to 0 plus, is equal to 0 plus means x greater than 0, which is this part, x greater than 0. So we need to find the limit of that part of the function, which is x squared, to this one. As x goes to 0 plus. All what we need now, replace x by 0, it will be 0. Now you can see that the left limit and right limit are not equal. This is the left limit. This is the right limit. They are not equal. So we say that now. For this limit, when x goes to 0 minus, since left limit, which is minus 1, is not equal to the right limit, that is 0. Minus 1 is not equal to 0. Since the left limit and right limit are not equal, we say that the limit, this will give me that limit f of x as x approaching the number 0 does not exist. So there is no limit for the function when x approaching the number 0. So the limit does not exist because the left limit and right limit are not equal. Now let's take another question now. In the same question, part B, I need to find the limit of the function f of x when x approaching the number 1. We go back to the function. When x approaching the number 1, means we are looking for x or for a value very close to the number 1. It might be 0.999 or 1.001. We are not going far away from the 1. I have this number 1. I have 0, I have 2, and 1 is in between. I need to find when x approaches the number 1 either from left or from right. But since the number 1 is not one of the definition points, we say this 0 or 2, sometimes we call it the definition points, where the function is changing before and after. But 1 is not one of them. So it means that no need to find or to look for the left limit or right limit. Left or right, no need to check or to find the left limit or right limit. All that I need just to see this number 1 in which part, in which interval. And you can see that it is between 0 and 2. Number 1 is in this part, in this interval. So my function now is x squared. So the limit for this case when x goes to 1 is equal to limit of the function x squared when x goes to 1. Replace x by 1, I will have 1 square, that will be equal to 1. So the limit for the function f of x when x goes to 1 is equal to 1. One more. See, what is the limit of the function f of x when x goes to 2? 2 is one of the definition points. This is x is less than 2. Okay, it is 2x. I need to rewrite this again, but there's a problem in this function now. This was x squared, 0 less than x less than 2, and 2x when x is greater than 2. This was my function. Now, for x goes to 2, which is one of the definition points, I have 2 parts, x squared and 2x when x is less than 2 or x is greater than 2. So this means I need to find the left and right limit. So I need to find the left limit f of x as x goes to 2 minus means the left limit and the right limit. And from the definition of the function left limit or the left part, the function is equal to x squared. Replace x by 2, I will have 4. As I said before, 2 minus means the left, it doesn't mean minus 2. Left limit means coming from the left, it doesn't mean x is equal to minus 2. It is 1.999, for example. And the right limit that was given, the function is 2x when x goes to 2 plus. Replace x by 2, this is 2 multiplied by 2, which is equal to 4. Now you can see the left limit and right limit are equal. Since they are equal, we will say that the limit exists. Then we will say limit of f of x as x goes to 2 is equal to 4. So the limit exists and is equal to 4. The f of x as x goes to 2 without any sign, without positive or without negative. So the limit f of x as x approaches the number 2 is equal to 4, and we say the limit exists because the left limit and right limit are equal. So when the left and right are equal, then the limit exists and is equal to that number.